Well, let's now have a look at the hyperbola. I'm not going to derive the whole thing like I did the last one. We'll go straight to the general formula, and it's very similar, you'll see. So the hyperbola, the only difference is instead of being plus, it's minus. So you got x squared on a squared minus y squared on b squared is equal to 1. But all the other things turn out quite similar. Notice e squared minus 1 instead of 1 minus e squared. Once again, you can't get that wrong. If you remember, eccentricity of an ellipse is less than 1. So if you were to go e squared minus 1 for the ellipse, you'd end up with a negative number. With a hyperbola, eccentricity is greater than 1, so when I go e squared minus 1, I get a positive number. So for the ellipse, it's 1 minus e squared, hyperbola, e squared minus 1. What that means is when I make e squared the subject, I get a squared plus b squared instead of a squared minus b squared. Again, because it has to be bigger than 1. If I had a squared minus b squared, then obviously the top would be less than a squared. I'd get something that's less than 1. So plus b squared for the hyperbola, minus b squared for the ellipse. Okay, focus is still AE0, that doesn't change. And directrices is still A divided by E, that doesn't change. All that changes is the relative position. So I was saying before, with the hyperbola, it'll be on the inside rather than on the outside for the directrices. Now we have additional things with the hyperbola. We have asymptotes. The one that we've been used to seeing, y equals 1 on x, the asymptotes were just the axes, so it was nice and easy. The hyperbola we're going to draw is on its side. Turns out there's that ratio again. Remember that ratio I used to draw the ellipse, b on a? Same deal, it's a really important ratio. It turns out to be the asymptotes in the hyperbola, b over a. That's if the foci is on the x-axis. If it's on the y-axis, this is how it changes. So it doesn't have anything to do with the size of b squared, a squared. With the ellipse, that's what mattered. Here it matters where the negative sign is. Okay? So wherever the positive is, that's where the focus is going to be. So if it was on the y-axis, we'd have y squared on b squared minus x squared on a squared. So the minus is the other way around. But again, we'll see things swapping over. So now we'd have a squared is equal to b squared, e squared minus 1. The foci again would be BE instead of AE. Directrices would be B divided by E instead of A divided by E. What else would happen? Oh, the asymptotes stay the same. Asymptotes are still B on AX. It's just that it would be in the other bits. And so it's still B on A. And I suppose our E squared, when we make E squared the formula, the top's still going to be A squared plus B squared, but it would be divided by B squared instead of A squared. Okay, let's do a quick one. Find the eccentricity, foci, directrices, etc. for our hyperbola. It is the standard one with x squared being positive. So a is 3, so a squared plus b squared on a squared. We end up with an eccentricity of 5 on 3, which is bigger than 1, that's what we're expecting. So eccentricity 5 on 3, foci a times, I keep saying the wrong way, a times e. Directrices a divided by e. Asymptotes now, we have b on a, so 4 on 3x. And look, only 3 questions. I told the second bit was quick, but there you go.